All right, this is activity. Oh, you can't see. Um, this is activity 622A, and here's where we finally get to a scenario where using the Laplace transform makes sense. So in this case, it's when you have u3 is a function that's 0 until you get to 3, and then it's 1. So for instance, it's like if someone flipped a switch, and so we've got no power, and then someone flips a switch at t equals 3, and we've got power. And then we can use the table from back in 6.1 to do this Laplace transform. So here we go. We've got that, so take Laplace transform, and we've got s squared x minus s plus 4 times sx minus 1 minus 21x equals, and then the Laplace transform of u3 is e to the negative 3s over s. Negative 3s over s. Okay. Then we solve for x. So we've got s squared plus 4s minus 21x, and then minus s minus 4 equals e to the negative 3s over s. So then s squared plus 4s minus 21 times x equals e to the negative 3s over s plus s plus 4. And then I'm going to find a common denominator, which is easier. So divide by s, then multiply by s. Okay. Then I can divide by this and divide by it in its factored form. So x equals e to the negative 3s plus s squared plus 4s all over s times s plus 7 times s minus 3. Okay. Then here's where we need to figure something out. Okay, so here we need to do partial fractions twice. Once for terms that have this next to it, and once for terms that don't. So we're going to solve two different partial fractions questions. So we're going to solve so here, I'm going to pause real quick. Okay, so basically what we're doing is x equals e to the negative 3s times 1 over s times s plus 7 times s minus 3 plus, and then the term without that term, so then the plus s squared plus 4s over s times s plus 7 times s minus 3. Okay, so we're kind of doing partial fractions twice. Let's get to it. So if I have stuff over that, then I'm solving a over s plus b over s plus 7 plus c over s minus 3. Okay. So then that means you've got a times s plus 7 times s minus 3 plus b times s minus 3 plus c times s plus 7. Okay, so that means you've got how many s squared terms? A, B, and C are all included in s squared terms. And then you've got how many s terms? You got 7s minus 3s, so 4a. Then how many regular s terms here is minus 3b. And then how many regular s terms there? Plus 7c times s. And then the only number term is a, so minus 21a. All right, so that means we know a automatically. So in this case here, a is 0. In this case here, a is negative 1 over 21. And then, but I think I'm just going to use Sage to speed things up a little bit. So pulling up the Sage. So m equals matrix, and so I've got the first s squared term is 1, 1, 1, and I'm going to solve both equations at the same time. So I'm going to solve the e to the negative 3s term, which has 0 s squared terms, and then the other term is 1 s squared term, as long as I keep them straight. So then the next term, the number of s's is 4 a's, negative 3 b's, and 7 c's. And then there's 0 for the first term, and 4 for the next term. And then for, I've got negative 21a, no b's, no c's. And then I've got a 1 there and a 0 there. So let's show MREF. Okay, so the first, the column with the right here, that corresponds to my e to the negative 3s term, and the column right here, that corresponds to my term without the e to the negative 3s term. Okay, so that means I can write, let me move this over, and then I'll kind of write this out. So then x equals e to the, so negative 1 over 21, e to the negative 3s over s, and then plus, make sure there's enough space there, plus 1 over 70 e to the negative 3s over s plus 7, and then plus 1 over 30 e to the negative 3s over s minus 3. Okay, so that's my first, that's the column there, and then I've got the 0, so I've got no over s term there, so just the plus 3/10 times 1 over s plus 7 plus 7/10 1 over s minus 3. Okay, so then I take the inverse of the Laplace transform, and anywhere I have this e to the negative 3s on top, if you go to your table from section 6.1, anytime you have an e to the negative 3s, that means you've got a u3 times that function with t minus 3. So that means little x equals negative 1 over 21 times u3 of t times, and then 1 over s would normally be 1, and so it's 1 shifted is still just 1, so that stays just the same, plus 1 over 70 u3 of t times 1 over s plus 7 would be e to the negative 7t, e to the negative 7, but not instead of t, it's t minus, it's t minus 3. And then here, plus 1 over 30, and then this term here means we get a u3 of t on the outside times e to the, it would normally be 3t, to be 1 over s minus 3, but now it's e to the 3 t minus 3. Here, this 3 comes from the s minus 3, this 3 comes from the 3 there. Okay, and then plus these last two terms. 3 over 10, that's e to the negative 7t, and then there, that's plus 7 tenths e to the 3t. And that is your answer.